We're going to talk about lesson 4.7 inverse trig functions today. You should have a handout at the top of it looks like this. Inverse trig functions. That handout includes both 4.7 and 4.8. First thing at the top here, it just tells us that if we're looking to find an angle and we know the ratio of the trig function, we can use our calculator to work backwards. Well, pretty much use your calculator if it's not one of our 30, 60, 45, 90 ones to figure out what it is, and it's the inverse sine or inverse. This is red, the inverse sine. That is, tell me the value of x, the angle that gives me a certain ratio. It's also called an arcsine. Sometimes your book will use inverse sine, sometimes it will use arcsine. Both of them are used in mathematics, so you need to make sure that you have you understand that they're the same thing. This is a good note. It says the inverse sine is not 1 over sine. Remember, 1 over the sine of x is the cosecant of x. So that's going to be different with the exponent being -1. It doesn't mean the same thing when we're using trig functions. A couple of examples. Find the measure of angle A, given that side A is 70 and side B is 55. The first thing we need to do is figure out, well, I'm looking for this angle up here. 70 is the opposite and 55 is the adjacent. So I can write the tangent of A equals 70 over 55. And now this is where we employ the inverse, and we say that A is equal to the inverse tangent of the ratio 70 over 55. So this is the regular statement that we have, and then we have a inverse, and now you can put that into your calculator and make sure that you're dealing in degrees because that's what we're measuring in. Mr. Nemenich says hi, and we get 51.84 degrees. Again, make sure that your calculator is in degrees. In this case, we're speaking in degrees, so if you put inverse tangent of 70 over 55 and you're in radians, you're going to get something much different. So that's the very general. You've done this in Algebra 1 and Algebra 2. We do take it a little bit further, as most of the topics that we've done in this class. Next one says solve for the triangle. Whenever you solve for the triangle, you need to find all of the measurements. You need to find 3 angles, and you need to find 3 sides. So it says be organized in your result. I like to just go up here for my final answer. D equals E equals F. What the? F equals, those are the angles, and then the corresponding sides that are opposite them. I'd have little d equals little e equals little f equals, we already have f is 17, we have d is 32, we have d is the right angle, and we need to find the other 3 things. So that's what we're doing when we're solving a triangle. First thing I should probably do is draw the triangle, and we should get things that we'll draw. So I have a right triangle, and then I can label it up. It said D is the right angle. Let's call this D over here, which makes that my right. 32 is little d. I've got, I can do E and F, which means I'm looking for little e, I'm looking for little f, and I need to, I know that little f is 17. To say we don't have quite enough information. Now we're good to go. I would start with using the Pythagorean theorem to find E. I need to find the third side whenever I have 2 sides of a right triangle. I can find that E is going to be equal to the square root of the hypotenuse squared minus the other leg squared. don't have to go right to this. We can set it up with e squared plus 17 squared equals 32 squared if you want, but we can cut to the chase here. I think this is the square root of 735, and I think that ends up being approximately 27.11 when rounded. So I found E, 27.11, 27.11. Next thing I need to do is find either angle E or angle F. I like to use the values that were given, so I don't want to use 27.11, which is rounded. So if I was going to find F, I know 17 and 33. Therefore, I'd have the sine of F is equal to 17 over 32, which means F is equal to the inverse sine of 17 over 32. Put it into your calculator. Make sure that you're in degrees, and I get 32.09. F is 32.09. E and F have to be complementary angles, so I'm at 32.09. So all I have to do to find E now is take 90 minus 32.09, and that's like 57.91. Boom, we're done. 57.91. Must show your work to find our little missing parts here. This guy, and then the last one was 57.91. Those were the three that was missing. This is solving a triangle, showing that we have all 6 important pieces of info, 3 angles and 3 sides. Solve each equation. Sine of theta equals the square root of 3 over 2. Again, we could use our calculator now and do inverse sine of square root of 3 over 2. But you also got to remember that we can just set up a triangle that says here's theta and sine is opposite over hypotenuse, and I know this is a 1, 2 square root 3, and I know this has to be 60. So theta is 60 degrees. Now you got to be a little bit careful because the sine of the angle is equal to positive square root 3 over 2. Where else is the sine going to be positive? It's going to be the y coordinate, so it's when it's in quadrant 1 and quadrant 2. What is a 60 degree reference angle in quadrant 2? I get 120 as well. You got to be careful for when they ask you these questions. Notice this one over here says find all solutions where the angle is between 0 and 360. They didn't really specify here. 60 is probably acceptable, but 120 would also work as well. Tangent, when is the tangent 1? Tangent is 1. Most of us probably know that it's 45. If you didn't know, just come down here. It's no big deal if you don't know. Set it up. Opposite over adjacent. 1 squared plus 1 squared, 2 squared, or 1, it's 2, it's the square root of 2. Oh, it's 45. So theta equals 45 degrees for that one. Don't forget, where else is the tangent positive? It's positive in quadrant 1 and in quadrant 3. Quadrant 1 and quadrant 3. So 225 also works. For this one, the tangent of 225 is also 1. If you don't believe me, you can check it on your calculator. Now find all solutions for this guy over here. For sure, we want to be careful. Sine is negative. When is the sine negative? That's when we're in quadrant 3 and 4. So we need to be understanding when is the sine negative. Quadrant 3 and quadrant 4. So when I do this guy, in quadrant 3, again, you can do the reference triangle if you don't like the other methods. I got opposite hypotenuse. This has got to be the square root of 3. Oh, it's a 30, but I need a 30 degree angle in quadrant 3 and quadrant 4. I need my theta to be between 0 and 360, which means in quadrant 4, I think I'm at 330. In quadrant 3, I'm at 210. Interesting to check to see what happens when you type inverse of negative 1/2 in your calculator. I think you get negative 30 degrees, if I'm not mistaken. And is negative 30 in between those two? No, but negative 30 is coterminal with 330, so you need to have an understanding of when the sign is negative in order to solve these problems. Okay, very important. Backside, just want to take a look at this little section. You can read through this on your own. Let's see what happens if we use two operations in conjunction. This is saying find me the angle that has a ratio opposite over hypotenuse of square root 3 over 2. And then it says take the sine of that angle. Well, if I'm taking the sine of the ratio, I'm looking for the angle, and then I'm taking the sine of the angle, I'm looking for the ratio. I'm going to get this. These two end up canceling each other out. You can draw a triangle to show this. If I do inverse sine of square root 3 over 2, and I set this up, and I get, well, it needs to be a 60-degree angle, which we have here. Okay, and now it says simple substitution, so it's saying put this 60 in for that thing and calculate the sine of 60. Hey, what's the sine of 60? Square 3 over 2. So we're going forward and backward. We're doing the same thing. So whenever these are the same, when we're taking the sine and then the inverse, you're going to end up with a half here. You're going to end up even going the other direction. The cosine of 60, well, the cosine of 60 is a half, and then it says do the inverse cosine of a half, because that's what the cosine of 60 is. You can see it up here on this triangle, if you can read my writing. So it has to be 60. So whenever those two things match up and one's the inverse and one's the regular, they're going to cancel each other out. This is pi over 4. Remember, pi over 4 is just 45. Okay, so there's a few other problems of those on the bottom. Now these are not same. It says find the exact values, inverse sine of square root 3 over 2. Okay, at this point, hopefully we understand that that is 60 degrees. We can plug it into our calculator. If we don't have a calculator, like the quiz is coming up in your near future, I can do, okay, here's my angle, square root 3, 2, 1. Oh, this has got to be the 60-degree angle that we're looking for. Now, these ones are a little bit more involved. Notice square root 5 over 3. We don't know much about that. You can do these without a calculator. Exact values, no rounded decimals. That's really important. You gotta read the directions. Inverse tangent of square root 5 over 3. So I'm going to set up an angle here, and I'm going to do tangent ratio, and it's going to be opposite over adjacent. And then we're going to find the hypotenuse by using the Pythagorean theorem. The Pythagorean theorem will be square root 5 squared, which is 5, plus 3 squared, which is 9, and then I need the square root of that thing. So I get the square root of 14. Square root of 14. And now it says I want the cosine of whatever this angle is. Well, I don't know what the angle is, and I don't need to know, because cosine, if I go from here, is going to be adjacent over hypotenuse. So the cosine of that angle will be adjacent over hypotenuse. Boom, we're done. The only thing left that we could do is we could multiply the top and the bottom by the square root of 14 and get 3 square root 14 over 14 if we really needed to. I would accept this answer. That's an exact value. Notice the square root of 14 is an irrational number. If we just did it with decimals, we would get an ugly decimal. We can't do it like that. Check this one out down here. Again, inverse tangent of a half. Inverse tangent of a half. Again, draw a triangle. Tangent. Let's go from this angle here. Opposite over adjacent. Hey, Pythagorean theorem. 1 squared plus 2 squared. That's 4 plus 1. Take the square root. I get 5. Now it wants me to calculate the sine of this angle. Well, that's the ratio of that angle. And we go, the sine from here is 1 over the square root of 5. 1 over the square root of 5. So work from the inside out. we did this inside first to form a triangle, then we calculated a cosine. Here we use the inside, the inverse tangent of the 1/2 to find the hypotenuse. After we have the hypotenuse, boom, we got it. Again, that could be written as square root 5/5. We're splitting hairs. Last one on here. When is the sine 1? At this point, we probably should know when the sine is 1. The sine is the y coordinate. That means we're going up 1. Think about the unit circle. Sine is 1, I believe, at 90 degrees. 90 degrees. So we should be able to get that one. Now, this is really asking me for the cosine of 90 degrees. Hey, what's the x coordinate at 90 degrees? It's 0. It's 0. So even though there wasn't really a triangle we could draw here because of the idea of the opposite over the hypotenuse being 1, we should have an understanding that the sine of 90 is 1. Think about your unit circle. Okay, so that's the stuff for 4-7. Kind of went through that. You should have no problem, or you should be able to work on your 4-7 homework now. Also 4-8, which we will talk about tomorrow, but those are angle of elevation and angle of depression problems, which you should be able to get yourself a start on those all on your own. So hopefully you're good with the inverse sine, cosine, and tangent.